and then you form these other intermolecular bonds between the negative of the oxygen side and the positive there, positive and negative charges here. So you get these attractions of the opposite charges.
Okay, Mr. Mitchell, you know what? You can use your sciencey terms like molecule and charge, but that's not going to mess me up this time because of my involvement in our recent water races lab. I was fortunate enough to be with Group 1 and Period 1, which consisted of Brian Catlin, Brooke Andrews, and yours truly, Michael Bubant. I'm going to let my group member, Brian Catlin, explain what we did on the surface level and how we did it.
Thanks for doing.
We are doing a water lab where we have to push the water across the racetrack, and obviously our water is superior, so obviously we're gonna win.
Alright, I got you.
Wait, why is it we?
Alright, there's a couple extras. Here's your race cars. And there's your finish line. Make sure you get a good shot as they cross the finish line.
And in slow motion.
It's important to note that our finish line was made of soap, but that obviously didn't stop Brooke and I from gambling our lives away.
I'm so happy, oh, happy, lucky me. I just go my way, living every day. I don't worrying don't agree. Things that bother you never bother me. Things that bother you never bother me. I feel happy and fine, ha-ha, living in the sunlight.
However, despite these destructive habits, our race was fortunately able to continue.
Yo, she cutting through the lines! She's cutting through the lines. Come on, Brian. Come on, Brian.
Oh no, what did you do?
Why are you moving it?
I want you
Stop!
you have to tell me what happened on the molecular level.
No. It fell apart, I win.
That was mine.
You cut through
Disqualification.
Yo, you cut through first. You cut through
Disqualification.
first, bro.
Although the race yielded inconclusive results given that both parties cheated, it is interesting as to what it says about hydrogen bonds and how they create the properties of cohesion and surface tension, and how that relates not only to water but other matter. Hi, my name is Michael Bubant.
And I am Brian Callan. In our lab, the water race, we used soap molecules and water molecules. This is a soap molecule, and this is a soap molecule as well with hydrophobic and hydrophilic ends marked and separated. In this, you can see that there's negative and positive charges on each of them, which attracts the water molecules.
And some interesting parts about the race and the reaction between water and soap. Hydrogen bonds are easily broken, so that's why when the water went over the soap, it broke up a bit. And soap weakens the surface tension of water, which makes sense logically. Soap, if you've ever used it, is obviously slippery. And hydrogen bonds. The hydrophobic molecules push up to the surface, which weakens the hydrogen bonds holding together at the surface. The soap in water results in a break in the surface tension of water.
Thank you.
Thank you. Because these properties of cohesion and surface tension are a creation of hydrogen bonds, you might be wondering what exactly a hydrogen bond is. Well, that's a great question, and a boring one, but a good question nonetheless. Hydrogen bonds are actually relatively a very simple concept to grasp. It's the bond between two atoms, one of which being a positive hydrogen atom, and the other one being any electronegative atom. In our case, obviously, that would be oxygen. Because a water molecule is polar, and polar meaning that it has an electric or a negative charge on the top and a positive on the bottom. Because it is polar, it can have as many of these hydrogen bonds as it wants, and these hydrogen bonds are what makes water extremely weak. And because it's weak, it can go out of its normal cohesive state, which is where it will attract more and more and more of itself. It can get out of the state and become adhesive because of surface tension. Oops. That handwriting. Looks like a little kid wrote it, but it works. So, as you saw in the video, the finish line was made out of soap, and this was intentional. Soap automatically makes water adhesive and break away from itself when it goes over it because of how weak that hydrogen bond really is. And if you also were paying attention, you saw that when Brooke and Brian were blowing on the droplets of water, it broke apart almost immediately because they were blowing too hard. Even blowing on a droplet of water can cause those hydrogen bonds to split up. And because of that, it'll get out of its normal cohesive state and go into an adhesive one, breaking up into smaller and smaller and smaller droplets. To an outside observer, this lab may not seem like much more than us blowing on droplets of water on a piece of wax paper, maybe just to entertain ourselves. However, it's so much more than that. We learned about what hydrogen bonds are, how they're created, how they're destroyed, how adhesion and cohesion are created from them, how surface tension is created from them, how polar molecules have to do with hydrogen bonds. We learned a lot. This very basic part of water, that water can break up, is something that we've seen almost every day for our entire lives. It's such a basic part of water, it's such a basic part of a lot of matter that it's very interesting that we were able to get to the nitty-gritty and see why exactly all of this happens. And the majority of this video was recorded on Apple. The only part that wasn't was the part of me explaining what hydrogen bonds are. This video was edited on Apple, and I hope not only that you learned something about hydrogen bonds, but also that you learned that Apple is much better than Samsung. Thank you.